Over 200 years ago, the advent of engines transformed the maritime world. But naval designers still needed a greater understanding of how their ships moved through the water, so they could install enough power.
For centuries, shipbuilders had a kind of one-size-fits-all notion about ship hulls. There was one generic shape that was considered the most efficient, but there was no real way of testing this, of working out how much drag, how much resistance a hull would encounter as it moved through the water.
In 1870, engineer William Froude tackled this problem, building a groundbreaking facility that would set the benchmark for hydrodynamic testing to this day.
It was here at his home in Torquay that Froude built the world's first tow tank.
The 76-metre-long water tank allowed Froude to carry out precise tests at consistent speeds. Handcrafted models were mounted on a carriage and dragged through the water on a steam-driven pulley, enabling Froude to make his hydrodynamic calculations.
Froude's original tank out there in the garden is sadly no longer in existence, but we do have this lovely swimming pool. And here we're going to try to explain Froude's revolutionary discovery and how it changed the world of shipping forever. We've got three different shaped hulls: a flat-faced square box, a slightly streamlined rubber duck, and then this sleek speedboat.
After ensuring they are equally weighted, each object is towed by a rope attached to a scale, measuring the amount of hydrodynamic drag.
You can see this isn't slicing through the water, it's sort of making a load of turbulence. If you look at the scales, 3, maybe even 4 kilos. That's a lot of drag, a lot of resistance.
Next up, the slightly more streamlined rubber duck.
Well, that feels much lighter, and the scales bear that out. Maybe 1.5, 2 kilos of force there. And you can see the pool much less disturbed. There are far fewer of those eddies. The duck's just skimming across the top of the water. But I still think we can do better. Let's try the powerboat. And this is almost effortless, maybe 600 or 700 grams tops. You can see much less disturbance to the water. The pool's almost still. And even from this scale model, you can see why we make boats in this streamlined shape.
Although Froude appreciated the importance of friction between hull and water, his real breakthrough was understanding the drag illustrated by the model's wake pattern.
Froude's real eureka moment was when he realized that he could use a law to relate the drag on a scale model of a boat to one that was full size.
His ingenious formula created what has become known as the Froude number.
That Froude number can then be used to compare a model ship to a full-size one. By making sure they've got the same Froude number, you can work out how much drag the larger ship will experience, work out how big an engine you need to install, and it was this discovery that revolutionized hydrodynamics and the shipbuilding industry.
During the 1870s, Froude's groundbreaking innovation was home to over 46,000 experiments. His pioneering work paved the way for hundreds of state-of-the-art tanks in existence today, many of which have been christened with water from Froude's original tank.